Okay everybody, I was just another little video. I've had to do a repair on this machine. It's a sandblaster. So all the shot pellet, you can see it on the ground. It's like a shot that comes out of like gun shells and stuff like that. Anyway, this machine here has 4 wheels so that the wheel will spin around like this. So as the shot gets fed down, it gets flooded into the steel. So the steel here gets fed into here. We have a roller that is on a frequency drive. So we have this little frequency drive up here. And what that does is that controls the speed or the feed going into the sandblaster as it goes along. We have 4 motors. I've just put in a new motor, the one underneath there. We have 2 either side. So on the inside here we have a big impeller that spins around, and we have another one here. And as it gets fed through this little hopper, drops down a tube, hits the wheel, and it gets spun onto the steel tubing. So what we have in here, we had an accident where a screw fell across or vibrated out of the motor, shorted between 2 of the phases and caused it to blow the contactor apart. So what we've got a new 3-phase breaker because it actually welded it shut. A new contact. These are a Mitsubishi contactor. Big in America, but very hard to get out here in Australia. Had a lot of trouble getting them, so you can find. So we've got these 2 here start up. One for the feed pump up the top. All right. Another one for the blower over the back. So these 2 start up, and then we have what we call sequence starting, which means pump 1 will start, this timer starts, 10 seconds later brings in this contactor. When this contactor comes in, brings in this timer. This timer times out 10 seconds later, brings this in, this timer starts, brings the 4th one in. So what it is the delayed starting. Instead of all 4 starting at once, we have a delayed starting effect. So we have 1, starts a timer, 2, starts a timer, 3, starts a timer, 4, that starts, that's it. We have the frequency drive, alright. The frequency drive is wired up. It's just a very simple stop-start. We have a little pot here that adjusts the speed, alright. Emergency stop, dust collector that, and then the 4 pumps. So we're going to crank this up in a minute. We need to test it. We had the new motor. One of the problems we had with when the motor was ordered, I didn't realise that the feet on a wig motor and the end plate, sometimes they will change it in the factory. So the part number we ordered on this one ended up being a flange pump, which means it has the base here, shaft sitting down and feet, and didn't have the feet or the end plate. Anyway, we changed it over. Wig motors were really good about it. But they kept the original part number on there. So you really need to make sure when you order a motor, sometimes the part number on the motor might not be necessarily what you order. Never ever heard it in 20 years, but it happened. We've got it fixed now. So we're going to crank this up, see how it goes. First thing I've done is I've hooked up the 3 wires into the motor. It's wired up into delta, which means we have three bars running across the motor. Hook the motor up. The only problem is you've got to make sure it's running the right way. So what I'm going to do is called a plug test, which is we're just going to start it up, make sure it runs the right way. I'm going to lift the timer off the top here and basically just give what I've done, lift the timer off. I'm just going to give it a manual start so it can just get the motor to start and run, but not pull in and stay in. It's just to give it going and make sure it's running the right way. So when I pull the contactor in, it'll either run clockwise or anti-clockwise. We need to make sure it's running the right way. This side here they run it clockwise, the other side they run anti-clockwise because the motors are facing in a different direction. Alright, so a little bit of commissioning, good stuff to go. See down the end there, we had a large bandsaw. Had a problem with that this morning where the feed pump wasn't working on feeding the water onto the saw blade. Found out, basic mistake, all the water was blocked up, causing the feed pump not to work and not allow the saw to work. All good stuff. This is what you call industrial electrical. Alright, not your house wiring, it's industrial. And this is where you can learn experience in fault finding. So when you look here, you can see all your different stuff for fault finding, all right? This was bought as a universal box, so not all of it, everything in here works. If you have a look down the bottom here, we've got extra wires down the end there where they haven't got extra wires in. Therefore all extras. So this machine was actually bought as a project that never went ahead. So what I did is we commissioned it up, we got all the wiring done on it, we put all the motors in, and we've just made it for what we want to do in sandblasting, that's it, all right? Put an emergency stop down the other end here the other day, all right? We've got an emergency stop where a feed rate is, got another one on the front here. So I'm going to give it a crack and see where we go, all right? I'll talk to you soon.